do tell me if there is issue in the visibility. Yeah. Are you all here?
Yes,
So,
sir.
so the question we were doing, let me recall the question first. We had a continuous, is it visible? Or
Yes, sir.
a continuous T beam has the cross sectional dimensions as shown in figure, right? So then it's given, then you have the figure. This is the figure. This was 300, was it? This was 100, and this is 1500. It's all in mm. Then uh, the web dimensions are given to you, have been determined from the consideration of the negative moment. So that has been given here. So the span is 10 meters. Further, the design moments are they are 800 kilonewton meter. Now determine the flexural reinforcement requirement. What we have to do is we have to determine the flexural reinforcement requirements. So we have to determine the area of steel. In this question, it's given we are using Fe415 steel. Now we have reached to a point where we determined the we had determined first the flange width. What is uh, what is the amount of effective flange width that came around something 2067 mm last time when we did this, and that was way greater than 1500 mm, which we are considering in this question. So there is, we can take the flange width as 1500 mm, right? Now, we in next what we are going to do, we are going to assume the uh, width or the effective depth. Effective depth of the section is around, what is the overall depth of the section? D, it's around 700 mm. If we check again, this was total, this was 700 mm. So let's assume D as, for example, let's take it as 650 mm initially. Then, if we are assuming effective depth, which is from this point up till this, if we are assuming this to be 650 mm, if this is assumed as 650 mm, now this is again an assumption here at this point. This is an assumption. So, what would be the lever arm uh, for the movements? Because right now we cannot calculate the movement unless we assume certain things at this moment. What would be the lever arm for the movements? Z. And what is Z? Z is from the center of the compression till the center of the tension. This is Z. This is Z. Right? Clear? Is it visible? Everybody? If there is any,
Yes, sir.
okay. So now Z we can take as 0.9 times the effective depth, or we can take it as 0.5 times the effective depth. So that would be 0.9 times. Now what is D? 650. So how much would that be? Can you calculate? Yes, how much is this?
585.
5?
85.
85 mm is the lever arm. Now, why are we assuming the lever arm? Because we don't know the center of the compression right now, whether it's somewhere in here or it's outside this. We're just assuming it. If it was in the center of this, it would have been no problem. Then it would have been df by 2. वहां पर located होता, but we don't know it as of yet. Where is the compression? The center of the compression, because the section is changing. If the neutral axis is below this, you don't know what is the center of the compression there. Now we are just assuming the lever arm at this point. It's somewhere 0.9 times the effective depth, so it comes out to be 585. Now, what would be D minus df by 2? What would that give you, first of all? This is df. df by 2 is somewhere here. df by 2 is from this point till this point. So your d, which is from here till here, so d minus df, this is also df by 2, would give you this much. Now, let us first calculate what is d minus df by 2. Now, that would be d is 650, df 100 hai divided by 2, so it comes out to be 600. This is 600. It's coming out to be 600 mm. Now, what is the reason of calculating d minus df by 2? We first need to check whether our lever arm, what we have determined, is 585 mm, and d minus df by 2 is 600 mm. So let us take for an assumption, this was also assumption. Let us take the greater of the two values, the value of Z or Z right now, which is 600 mm. So you could have Z this, or you could have this, or it could be in between of these values. So let us assume the greater value right now for Z, it's 600 mm. So we are not taking that assumed value of 0.9 for the sake of simplicity at this time. Thereby, AST, what is AST? How would you get AST? You will get it by MU by 0.87 Fy into Z. If you recall in the code, you have an equation given, mu is 0.87 Fy AST, then you have a value d1 minus 0.42 something xu. An equation something like this is given to you in the code. Now, the other portion d1 minus 0.42, in that is the z value, which has been calculated for a rectangular section. But for a